PCB Way, prototype the easy way. When you shop with these guys, you can get PCBs, 10 pieces for $5. You also get fast turnaround times. You get CNC machining, 3D printing, sheet metal fab, injection molding. I myself love the 3D printing service. You upload your CAD file, choose your materials, and in 2 to 3 business days, your part is on its way. Thank you, PCB Way, for sponsoring this video. All right, guys, so welcome back. Again, I really want to thank PCB Way for sponsoring this video. Those guys have been great. They took a leap of faith with me. And yeah, thanks, guys. Anyway, so I've got some more stuff I'm going to do. Here's a new rotor. I'm going to put some magnets on the end of that one. I also have a new rotor for my Newman motor. A big old knob like this thing right here. And I've already got that really big one in there now. And I've also 3D printed a new rotor over here. These have my barrel magnets. These are 3/4 by 3/4, I think, or 1 inch by 3/4. These are really powerful magnets. They're all N52s. So yeah, of course I got this big guy right here. I also have this guy too I want to fire up again, but I'm going to have some, I made some 3D printed clamps too. I did it out of PLA. I should have done it out of PETG. But I'm going to have some issues here coming up shortly. I'm getting ready to move, and which means all of this whole shop, which is a freaking nightmare. I mean, I got tools everywhere. Oops, got all these clamps. I've actually started moving already. I had tools all up there, but we're moving into a much bigger house, which is going to be nice, big, giant 2-car garage. So I'm going to have plenty of space to really set up a nice shop, or set up a shop. I don't know how nice it's going to be, but it's going to put a kink in my ability to do my hobby out here and film for you guys. I've been looking at renting out garage space, and I have a couple of nice opportunities that I may jump on. I'm actually going to be still living in my house while we're selling it. We're going to stage it with some of our own furniture, and my realtor says I can live there. My wife and my son are going to go stay with a friend, but I'm going to stay here until it's actually sold. But that doesn't mean I can keep my garage like this. This has got to be all emptied out. But I may be able to still do, you know, video production, yeah, if you want to call it that, in my current office. So yeah, let me I want to set this guy up, this guy next, and then I also want to change out the rotor for this guy here. That's a big ass rotor. I got to be really careful with that. All right, so stay tuned, guys. All right, so I've got this guy hooked up to my my bifilar coil, which is also a run coil, to a single JL94 over to the, wait a minute, you guys can't see that, over to the bridge rectifier, and I have it running off of my super cap bank. So let's see how it goes. All I gotta do is just hook it up. And it's putting out 150 volts DC. 160 volts DC. Not very strong though. Yeah, sometimes you just have to get it going. And it's the maglev. I don't know how much is left on the super cap bank. I think because I charged it up to like 13 volts, it can take up to 16. But yeah, it's going good, and it's pumping out 163 volts DC coming out of the bridge rectifier. Now, of course, there's no real amps coming out of there. It's 163 volts, but hardly any amps. I have some other 500 farad, 2.7 volt, 500 farad. These things are killer, and that's what this power bank is made of. Must be running down. I love this maglev, and this is a hollow tube. Now I can hold this, but this particular one spins better with all 4 bearings spinning and running off the maglev, or bouncing off the maglev, if you will. Starting to wind down. Let me get another multimeter and see how much is left on the see how much is left on the old I can't do it with the camera in the way. Yeah, I can't do it with the camera in the way. And the way I'm set up right now, I can't really go around the camera. It's a pain in the ass. I'll be so glad when I'm in my new shop. Oh, it's going to take a while to set up, but I'm going to have so much room. I'll be able to start doing woodworking again. Because this whole workbench was originally set up for woodworking. Underneath this panel right here is a DeWalt table saw that raises up on jacks. Yeah, we're running low now. Let me see if I can get this stupid camera out of the way. See how much is left on there. Probably not a lot. It says 9 volts. I can't believe that. All right, stay tuned. All right, so the 9 volts may not be any good for the single JL94, but the double, it works great. And again, I've got to plug this guy in here so I can see how much power I'm getting out. Yeah, 133 volts out. Oh man, I really got to get my freaking together. Where the hell is that? Oh, here it is. Come on. There it is. 132. I don't know if you can see that. Yeah, there you go. 132. Plus the 2 lights that's lighting up. So this is a this is a bifilar coil that was wound by Sky Collection, and this is my copycat of it. This guy's running off into the bridge rectifier, and this guy is just running the other side of the JL94 circuit. Running off of 9 volts now, probably down to 8. Yeah, that's really nice. That is really nice. Again, running off of 1, 2, 3, 4 bearings. So you got 2 bearings in the rotor, one up top here, and one down at the bottom there to support the maglev. Still putting out 132 volts. Again, no amps, or very little amps. But yeah, running off of the no power supply. Power supply is way over there. It's running off of the super cap bank. Probably around 7 volts on there now. And I'm going to run the same setup on my Newman motor. And I know I'm running my Newman rotor wrong. I'm supposed to run it off of a commutator, but I like using the JL94 circuit. And it's lighting both of the lights too. Normally when I do this, I'll only light one of the lights because I don't know why, because here, let me bring this down a little bit. There you go. Let me see if I could, let me get my other meter out. Oh, not this one. Here we go. Oh no, I left this one on. Dag nabbit. Alright, let's see if I could still find out how much is on there. Oops. Sorry guys. Alright, let's see what we got. DC. Oop, wrong way. Yep, 7 volts. 7 volts. So it's going down, but not fast. And that's pretty good, being that it's running a dual circuit. One of the lights is starting to go off a little bit. Oh, man, when I get my new shop set up, I'm gonna build a what do you call that thing? A cradle or a boom. I'm gonna build a boom. It's going to be above me so I can move the camera up, down, and around wherever I can. I've seen it done. I learned everything I know on YouTube, which isn't much, but I have fun. Of course, not everything. I built this. This is my own design, and all the rotors are my own design. But this coil is from Sky Collection. You guys know who he is. If you follow my channel, you follow his. And it's going good. It's still going, probably down to about 6 volts now. I don't have, the rotor should be down a little bit more because it's kind of running off the top of the coil here, which is not bad. It still works. I'm still getting output on the lights, 130 volts on the bridge rectifier. All right, I'm going to have to charge up the cap again to run this bad boy. I'm going to do the same thing. I'm going to run it off of the dual JL94 circuit. Still have to figure out what I'm going to do with these. I had them in my own rig. It was a wooden rig like this, but the way I soldered each of it didn't come out very good. Not a very good solderer. Got to figure out what magnets I'm going to put on this guy here. I might not even do anything with that thing. I definitely want to put this puppy in there in the Newman setup. Hope it doesn't fall apart. I've got it screwed down, so it shouldn't slide out. All right, guys, stay tuned. All right, I'm printing out another rotor. This time the rotor is going to use barrel magnets, but the magnets are magnetized differently. They're magnetized through the length, like that. See the line there? I don't know if you can see it. But yeah, it's magnetized through the length. And what better way to do it than on my A1? I haven't run this poor Ender V2 in the longest time. It's funny because I have an Ender 2 Pro still in the box. It's a mini, like the A1 mini. So I'm trying to sell it. I'm gonna take the money from that and buy a A1 mini and probably replace. I'll keep the Ender, and when I get into my new shop, I'll set it up to run, you know, projects that don't need any type of speed. So yeah, I haven't run that poor thing in a long time. Anyway, back to the rotors. All right, guys, so I've got this beast in here. These are, I think these are 2-inch by 1-inch. Oh, let's just find out how much they are. These are, whoa, yeah, they're 2-inch by 1-inch by, I think, 3/4. Yeah, so they're really big. And I made this guy here, so let's see what we got going on here. I got it hooked up to a single JL94 circuit. You can see it's freaking really going. It's only doing on 10 volts. And this is a half a coil. It's half of a Newman coil. I forgot why I did. I think this was the first one I ever wound like this, because it's not as good as these. And this is bigger wire too. And it definitely needs some support. Let me see if I can. Yeah, if I hold it down, it won't make that noise, but. Yeah, this is a beast. I want to get this guy inside this guy here, the bigger one over there. But I wanted to get it running on here just to see. It's funny because with these JL94 circuits, you got to get them going. Once you get them going, then they start flying. And I have the output. This is one of the single JL94 circuits that does have an output on it. This is a Sky Collection circuit. And there's a wind coming off of that thing like you wouldn't believe. And if I put it close to this guy, I might even be able to get him to even go with it. Let's see how long I can keep it going, see if it's got it actually caught up with it. No. Oh. No. All right. I really don't want to mess around like that anyway. But yeah, that's a nice rotor. I want to get it inside this one here. So let me turn this off and figure out what I'm going to do next. I got to get these guys out of here. Anyway, stay tuned. All right, so this always happens. I start a project like this, and then I go, wait a minute, this would be better if it was, because I have 4 of these huge magnets. So I made another one, and I just put the screws in there so it doesn't come out. So I'm going to take these 2 off, put them on this end here, and I think I measured it. Yeah, I measured it right. So, but I'm making this one to have bearings in here so it'll really spin, because right now this one spins with the shaft. And normally I don't do that. I make them so that they, like this one over here, I make it so that it has bearings up here, down there, and in the rotor itself, which, has a positive and a negative. But I'm definitely going to take this apart and put this guy in here. Then I can also use it in this one here. I can also use this 4-way one inside here. So yeah, just wanted to give you a little update on that. Stay tuned. All right, so I've installed the four leg version. This is a beast. Actually, its new name is Jerry. A viewer said I should name it Jerry because this is a Newman motor, Newman and Jerry. Anyway, Jerry is a beast. And I was kind of nervous because someone else said, and rightly so, if one of these came flying off, it would be brutal. So instead of just screwing it on one side, I screwed it on both sides. But again, I'm not going to stand anywhere near it. There it goes. Let me get the camera out of the way, just in case. It's got a little bit of a knock going on because this isn't secured down, but 10 volts, 0.11 amps going in, or I guess that would be 100 milliamps, 10 volts, putting out some decent output. I'm not measuring it, but I'm just going by the bulb there. I like it. It's big. It's got a lot of wind coming off of it. It's a monster. So let me turn it off because I want to get it off of here and put it inside this beast right here. And that guy's already got a beast in there of a rotor. All right, and I'm going to use the dual JL94 circuit on this guy here with this puppy in there. And I'll put the top on, obviously, because I'm still not 100% convinced that the, oops, sorry guys, that these might not come flying off. They shouldn't. They're pretty, make sure that this is all, yeah, it's nice looking, especially from this angle here. It is a beast. Again, those are 2-inch by 1-inch by 3/4 inch, I think 3/4 inch bar magnets, N52s. I only get N52s, and I get them from Total Element. And oh yeah, and this one is different too. So I can hold this and it still spins. So it's actually spinning on 4 bearings versus this guy's only spinning on 2 bearings because it's stuck to the shaft. It's sealed to the shaft. Where this one is like these guys over here, which are I can hold, which are done on 4 bearings. So yeah, 2 bearings on the actual rotor itself, 1 on each side, and then 1 on here. So I can hold it or I can let it go, and it's using all 4 of the bearings, which really gives it a boost in performance, I think, anyway. Anyway, let me get it switched over. Stay tuned. All right, so right now I've got this Jerry of a beast, or beast of a Jerry, whatever you want to call it, inside my actual Newman motor. These are 2 coils. I have it hooked up to the JL94 circuit, the dual circuit. So I've got one circuit on the top coil and one circuit on the bottom coil. I know that's not the way you're supposed to set up a Newman motor, but let's give it a fire up and see what happens. Yeah, with the dual coil, it's much more powerful. Even at 10 volts, I'm going to turn it down. Putting out a lot of power, though. Nice and quiet, especially for such a beast. And what I want to do is I want to charge up my super cap bank and run it off of that. Let me turn it up a little bit. There's 12 volts. Yeah, I'm afraid it's going to explode on me. I'm going to turn it off. I'm going to turn it off. It's a little too crazy. Yeah, that is a beast. Anyway, that's kind of cool. What I'd like to do though is hook up my bridge rectifier to one of these and just run it off of one of the circuits and see how much power I'm getting out of the coil itself. Put this down over here. Get my bridge rectifier. Get that guy set up. This is the AC side right here. So I don't know. I'll either run it off the top one or probably the top one. I'll put you guys on pause for a minute. Stay tuned. So now I've got it running off of just the bottom coil. The top coil is collecting not too bad. What is that? 22 volts DC. 12 volts coming in. Well, 12 volts plus 250 milliamps. I don't know how many amps are coming out of this because I don't have a way to. I mean, I had a clamp on amp meter. I don't know what I did with it. But yeah, it's putting out 20 volts off this top coil. I wonder if I switch things up, if the bottom coil will put out more. All right, hold on a second. Let me change it up. Yeah, so it's about the same. A little over 20 volts coming out of the bottom coil now. And it's running off the top coil. What I could do is see if I can run it collectively off of the other side of the circuit. I think I tried that before. It didn't work out too well. Still up there. It's a lot of weight for that PLA. Let me turn it off. That's a lot of weight for PLA to be taken. Anyway, thanks for watching, guys. Ciao.